Hi, my name is Susanna Gordon, and this is my Lab 3 video for our Physics 2212 class with Professor Junker. So let's get into this. This lab was definitely a lot more hands-on than other labs we had, and was a bit confusing to follow at times. So basically, we're finding the distance dependence of the magnetic field from our experiment, and we're comparing it to the value that we had from our Biot-Savart calculations in our glow script code. So basically, we had to download this app. So you would download an app, and you would find and you would look to see whenever the x component would be 0, or closest to 0, because you're trying to line it up with the direction of magnetic north, so you don't have to account for that in your calculations. And then we also found the magnetometer chip, which is a location in your phone where it's measuring the magnet. So you looked at and you set up a rule, and you found when the distance was greatest, and where for both it parallel and being perpendicular to your phone, and that's where your chip was. And then when you would measure the distance from the bar magnet to your phone, it'd really be from the bar magnet to the chip. And the big thing we were using in this experiment was using that the magnetic field of the bar is equal to k, some constant, times r to the n. And if you take log of both sides, you can get to look a bit like y equals mx plus b form, where your y is going to be log of b bar is equal to log k plus n log r, and n can be your slope. So these are my measurements that I got from it, and as you can see, there's a lot of kind of rounding error too, or just a lot of error in general, because I may have not have found my chip in the right place, and I was also estimating some of the values too, because it was really hard to get it exact and to make sure that the magnet was in the same horizontal plane as your phone. And it was especially hard for the off-axis, so perpendicular values, and those were definitely off, but those had a lot more error associated with them. But basically, with all your values, you get this graph. And in your graph, I have slope of about -3, so that means my n is about -3. So that means that that's the dependence of it. And you can see it's a pretty straight line, so I mean, it did pretty well, or at least well enough for it, but my off-axis field values are definitely inaccurate, and you can see that later in my code. So this is all my code. I know it's really hard to see, but we had to make different, basically, we had to make different functions to calculate it and stuff. So to find the dipole moment, I used the equation they gave us, which is that really long equation with the dot product in there too. And basically what I would do is that I would use the mu value that I calculated using my measurements from the experiment, and use that here to calculate what the magnetic field should actually be from those distances that I think they should be, with saying that my distance was some value basically. And the coding part wasn't too bad, and then at the end you end up with this. So you can see my magnet is that little silver or gray cylinder, and then those orange arrows are the fields on axis. And then those blue arrows are all the fields that are perpendicular. You can see that for the on-axis fields, they're going in the same direction as mu, so which goes from south to north. But then for perpendicular, it's going the opposite direction, which is what we would expect from a dipole, basically. And you can see I found what my b should be at these different values. And for the most, there's error. There's error in everything and stuff, obviously, compared to my results. But these are there's absolutely no error. Everything we said was exactly right. These are the values you should get for those magnetic fields. And I'm sorry that my numbers are a bit iffy and stuff. This was a really hard lab for me to do, and it's especially frustrating to get values the way I would like them to. So, final question from this lab is, the first one is, what if I didn't compensate for magnetic north? Well, then my results would have changed, because then I would have to also factor in magnetic north into my calculation. So then my magnetic field net value would also have some of that from the Earth's magnetic field, and it also kind of tend to be more towards that way. It wouldn't be purely just from the magnet. And that's why we also wanted to have all electronic devices away from my phone, so that none of those magnetic fields altered it, and then we would have different results, and it would no longer just be the magnet. And if we were to stick two identical magnets together end to end, all the directions would be the same, but the magnitudes would be doubled, because all of a sudden you're going to have double the mu, because you have the exact same magnet. So there's no change in direction, only change in magnitude, which makes a lot of sense if you think about it. It makes the most logical sense out of any option of what could have occurred. Anyway, I'm sorry I went a bit over time, and I know this is a tiny bit long, but I hope that you enjoyed watching this video as much as you could have, and I hit every point that I wanted to. So thank you for watching.